Hey everyone, and welcome to This Explainer. Today we're taking a deep dive into a really critical lab distinction that honestly trips up even seasoned pros. We're going to decode the complex liquid that keeps us all alive. By the end of this, you'll have a crystal clear mental model of exactly how this all works.
So, I'm talking about the great blood divide, serum versus plasma. Quick question for you. Do you know which one actually contains the clotting factors and which one doesn't? Look, if you're kind of hesitating, don't worry about it. People use these words interchangeably all the time. But getting these two mixed up in a lab or on an exam, yeah, that's a major mistake that totally alters your understanding of human biology. Okay, let's dive into section 1, the foundation. What is blood really made of? Because, blood isn't just one uniform red liquid sloshing around in your veins. It's actually a highly complex biological suspension. It's made up of what we call formed elements. So that's your red blood cells, white blood cells, and platelets. And all of those physical elements are suspended in a straw-colored liquid base called plasma. The formed elements? They do the heavy lifting for oxygen transport and immunity. But plasma is the vital river they flow in. And that river is overwhelmingly made of one specific thing, 99. That's the percentage of water making up this plasma base. Think of plasma as the complete package of the blood's liquid state. Alongside that 99% water, it carries essential, life-sustaining minerals like sodium and potassium. They're all perfectly dissolved and ready to be transported wherever the body needs them, literally at a moment's notice. But that remaining 1%? That's where the absolute magic happens. You see, plasma isn't just water and salt. It crucially contains exactly 12 specific organic factors. And these aren't just random floating proteins either. These 12 factors are entirely dedicated to the blood coagulation cascade. They're basically the body's built-in emergency response team, just lying in wait to stop you from bleeding. So how do we actually isolate this complete package in a lab without accidentally triggering that emergency response? Well, we have to follow a very strict step-by-step process. Step 1, you draw the blood sample. But right here is the absolutely critical part. Step 2, you absolutely must add an anticoagulant chemical to the vial. This chemical essentially handcuffs those 12 clotting factors, stopping them dead in their tracks so the blood cannot clot. Finally, in step 3, you spin that vial at massive speeds in a centrifuge. The heavy formed elements sink right to the bottom, and that pure straw-colored plasma, with all its clotting factors perfectly intact, rises beautifully to the top. But what if we change the rules of the experiment? Let's move to section 2, the twist, the clotting cascade. When we simply let a vial of blood sit there and clot naturally, those 12 factors wake up and get straight to work. The absolute key player among them is a biological compound called fibrinogen. Fibrinogen is a crucial clotting factor that works alongside the others to form a literal cellular mesh. Just imagine a microscopic net being rapidly woven together right inside the vial, physically trapping the blood cells together to create a solid, immovable clot. And once that net is fully built and those cellular elements are totally trapped, something really fascinating happens. As our source material describes it, a clear, pale yellow liquid starts to ooze out of it. That oozing liquid, well, that's the grand reveal of our explainer. That is serum. It's literally the liquid left over after the exhausting work of clotting is entirely finished. Which brings us to section 3, the reveal, the magic key formula. Here it is. We call this the magic key. Serum equals plasma minus clotting factors. So the absolute crucial point you need to remember is this. Serum is essentially the exact same liquid as plasma, but it's fundamentally missing those 12 clotting factors. Why? Because they were entirely used up in the process of making that cellular mesh clot. Plasma has the factors. Serum has spent them. It really is that beautifully simple. Now, why does this distinction matter outside of a biology textbook? Well, in the real world of medicine and diagnostics, this difference is absolutely everything. Medical pros specifically demand serum when they need to measure your antibodies or check your delicate electrolyte levels. Why is that? Because if they used plasma, those bulky clotting proteins, like fibrinogen, would still be floating around in the sample, causing super frustrating chemical interference and just muddying up the vital test results. Serum gives them a beautifully clean, interference-free biological window into your health.
All right, let's wrap this up with section 4, the ultimate comparative analysis to perfect your notes.
And this brilliantly illustrates the exact differences we've been exploring today. Just look at this direct comparison. Plasma is the liquid derived from unclotted blood. It's full of fibrinogen, and crucially, it requires that anticoagulant chemical to be isolated in a lab. Serum, on the entirely opposite hand, is the liquid derived from clotted blood. It completely lacks fibrinogen because, remember, it was entirely consumed, and therefore it needs absolutely zero anticoagulants to be produced. Seeing it like this, the entire mental model just kind of clicks into place, doesn't it?
Which brings us to our final test of understanding. We've seen how plasma fiercely holds the factors, and serum is just what's left after the clotting work is all done. So here's a provocative, practical application question to test your new knowledge. Based on the mechanics we learned today, which liquid, plasma or serum, would you expect to find in a person with a severe vitamin deficiency that completely prevents their blood from clotting? Think really carefully about the mechanics of the cascade and that magic key formula we just covered. I definitely want to see your answers and your deductive reasoning down in the comments. Keep up that intense focus on your learning, and I'll catch you in the next explainer.